Hello and welcome back to the tutorial on writing your own operating system. Now in this 8th video we are going to clean up the whole project a bit because if you look at this project it's getting more and more cluttered. I mean it's not very bad right now, but it's over time it will become more and more cluttered and confusing, so I think we should really tidy up early on so that we don't get into a situation where we cannot unravel this anymore. So what I'm going to do is I'm going to create 3 subdirectories, one for source files, one for header files, and one for the generated object files. And this is really common practice. But I'm going to do this later in the video. First, I'm going to do some abstraction for the drivers. You know, right now we have a keyboard driver and a mouse driver, and they are very they stand on their own. You know, I want to have a little abstraction, have a common base class driver, and then have a class for driver management, which will basically be an array of driver objects, and then we can put the keyboard driver in there, we can put the mouse driver, and any other drivers that we will write later. Okay, so this is what I'm going to do first, because this is really the more interesting thing, and the stuff with these subdirectories, this is kind of boring. So when I create these subdirectories, I will also put namespaces around the classes which correspond to the directory names, and then we have to change these security lines here. These, if not defined, then define stuff. This I want this to correspond to the directory names also, so that they are definitely unique. This is what we are going to do now. So let's start with that. So I'm gonna create 2 new files. Driver.h and driver.cpp. So for drivers, I'm going to have only a few methods for the base class. One being void activate. You know, the here I want to put this this code for the activation of the hardware. One method reset, because what you usually do is when you start your operating system, you will enumerate the hardware. And I mean, you don't really know the state that the devices are in, so you just reset them, and you need to wait about 50 milliseconds after that, and then these devices are ready to run, and you know the state that they are in. So this is really for your security. So it could happen. It's theoretically possible that you start an operating system and you shut down that operating system, and maybe it goes back into the bootloader, and the bootloader then somehow decides to run your operating system. The Linux kernel I think it's capable of doing something like that by now. It's so you can do kernel updates without rebooting your computer, and this would be a scenario for that. So then, maybe what if the operating system that ran before you didn't clean up everything? So maybe the hardware isn't in the state that you expect. So then you just reset the hardware, and then everything is fine. And by the way, I'm going to have the reset return an int, which is going to tell us how long we should wait until we proceed with the boot sequence. Okay, so this is the less interesting part here. But we'll also have a driver manager. And since we don't have dynamic memory management yet, I'm just going to do this. I'll just have a fixed length array of drivers. Or pointers to drivers, to be precise. Let's say maybe 265. It's always a good number. Okay. Okay, so this looks good. Now we can put this in the make file. I think it should be relatively far in the front, so maybe here, and include it in the kernel. Okay, now we add the keyboard to the driver manager. Okay. Now, in order for this to work, we need to say that mouse drivers are drivers. Okay. Okay. So now I'll put this into this activate method. Okay, so this looks good now. The kernel is going to call to tell the driver manager that the driver manager is supposed to activate the drivers now. Okay, now maybe we want some status message in here. So let's have something like a line feed here, and then stage 1, stage 2, and stage 3. I think if you remember back in the day, I think Windows 95 or something around the time had similar status messages here in the boot sequence. Okay, let's see if this runs. Okay, as you can see, we are going through the stages, and obviously the hardware is initialized because I can use the mouse here. This keyboard interrupt 45 is not ignored again. Whatever, not so important. The important thing is that the initialization of the hardware is now a little bit more abstract. So we now have an array of drivers, and mouse and keyboard are just derived from this driver class, and so we can just later put different we can just put more drivers into this array, and this will really take care of most of the stuff for us. So this was one thing I wanted to do. Another thing, now you see we had this printing of hexadecimal values here, and we also had this in the interrupt manager. And I really want to take that out of there and put it to the other printf method. So I'll just copy this and have a method for printing a single byte in hexadecimal. Okay, this is going to become a bit ugly. I mean, if I'm whatever, I'll just do it the ugly way. Okay, so now in the keyboard we can just replace this with so then we have to put the forward declaration also here. And also in the interrupts file. Okay, and what I've also talked about already is this whole thing is really very messy right now because, I mean, it's really not a good idea to have the keyboard driver print the keys that you pressed directly to the screen. I mean, what if we put a graphics mode in between and want to have some desktop or something, then this isn't going to help you in any way because, then the keys are in a part of the memory where you don't see them. So, so the object-oriented way of handling with the situation is just having a new class, like a keyboard event handler. And then this is just going to have methods, virtual methods for on key down, on key up, the usual stuff that you see in object-oriented frameworks like JavaFX and Qt and .NET, and everywhere you see this design nowadays. So let's have this here also. And then the keyboard driver is just going to have a keyboard event handler. Okay, and we'll pass this event handler to the keyboard driver through the constructor. Oh, and these need to be virtual, of course. Okay, the keyboard. So an interesting question would now be, what are the parameters for on-key down and on-key up? I think it would be a good idea to have some internal enumeration for all the different keys and pass one of these enumeration values over there. But that would be a little bit overkill for this small project, so I'm just going to have a single character here. Okay, and the default implementation will just ignore these events. Okay, so now we have stored the handler. Okay, if we don't have an event handler, then we can just return. Okay, so in the remainder of the method we can assume that a handler is there, and then we can just replace this printf with okay, and I'm going to replace all the printf calls here. So I'm going to replace printf with handler on key down. Okay. So from now on, if we press a key, it's just going to be ignored for now. If we want to have it recognized again, then we will have to do something like this. We'll just extend this keyboard event handler class. And here I will just put the code right in there with the class definition. Okay, let's see. On key down. Okay, let's see if this works. Okay, so this works now. So the keyboard driver now doesn't print its keys directly to the screen anymore, and this is really a good thing because now we can change this behavior however we want. You know, we'll just if we want the keyboard to do anything else, we just derive a different class from the keyboard event handler and then just do something else whenever a key is pressed. And this will be, for example, very useful when we have a graphics mode and we want to pass the key strikes to any applications instead of printing them to the screen. Okay, and now we will really do the same thing just for the mouse. And for the movement. Okay, and then we will what are we doing? I know we already have X and Y down here, so okay, so this looks kind of okay. You know what, I'll just put another method in here for onActivate. Okay, and now we will just move this all this explicit stuff where we access the screen directly. We will move that again into the kernel CPP. Okay, so this in the handle interrupt. What are we doing here? Okay, again, if we don't have a handler, then we will just return here. Okay, here is on mouse move. Code. Okay, I'll extend the on mouse move to have parameters for the old values of x and the new values of x and y. Okay. Come to think of it, I think it's not really a good idea to store values for x and y in the keyboard driver. I think this really should be stored in the event handler. So I'll move this up here. And then these aren't needed anymore. Okay. And these aren't actually necessary in a general mouse event handler. I'll put them in here. So then these will just be offsets. Okay, switch the old values. Okay, so the mouse event handler should not worry about whether the offset is positive or negative, so we will just enforce it to be given in the right way. Like this, buffer 1 and minus buffer 2. Okay. Okay, so then we would have like this. And here. Okay, so this looks good. So if a button is released, we go to the event handler. Okay. Let's see. Okay, doesn't work. Okay, I found the problem, I think. So the data port read was skipped if there was no, but that cannot be the problem. Okay, I found the problem. This is really ridiculous. I instantiated the wrong class. Okay. Okay, so everything works as expected again now. Okay, so this took a little bit longer than I expected. Well, I'll just do this stuff with the directories and namespaces and everything just in the next video, okay? So, because I think this is really enough for one video now. So, yeah, see you next time, and sorry about the delay. Watch the next video, so then we will really have the whole system cleaned up. And don't forget to subscribe so that you don't miss any of the next videos. See you next time.